Welcome everyone in my data Adda channel. Today I am going to discuss about the Gini impurity. This is the heart of the decision tree algorithm. The last tutorial I just theoretically explained the decision tree algorithm. So actually Gini impurity help to split the data set. Okay. And today I'm going to explain how internally Gini impurity works. Let's start. First, imagine you are a bank manager and you have the data set like initial customer data group, like customer A, credit score is 800, loan default no, okay, like no, 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 then again yes. So actually, the data set uh, for whether customer is loan default or no, and our decision tree actually have to predict whether the customer is a loan default or not, will default or not. Okay. So before actually in the training stage, how the decision tree split data set and learn this, and uh, so this is the aim of this tutorial. So first thing you have to know, that is the pure and impure things or group. Here you can see this data set. Actually, the initial data set is a mix of classes. Actually, as here I am just only discussing the um, categorical or classifier uh, ML model. Okay, it will only identify whether the customer will default or not, yes or no questions. So that's why if the data set have both the class yes and no in the this type of data group is called the impure group. And if the dataset only have any specific class like no or yes, then we can say that is a dataset is a pure. So initially all the test customer are in one group, right? In the left side. Let's count them. Default equals to yes and count is 5, and default no is also count is 5. This group is mixed, as I said. So this entry does not like mixed group. Actually it wants pure groups, either all yes or all no. So our goal of this decision tree, or whatever I mean here, the Gini impurity, is to find the pure group. Okay. So again, I just explain what is Gini method. So Gini impurity asks how mixed is this group. More mixed is high Gini, and more pure the Gini is low. So what does Gini mean? So if the value is Gini is 0.00, then that means it's perfectly pure. It's 0.10, that means very pure, 0.20 mostly pure, and 0.5 highly mixed. So for our initial group of 10 customers, you can see there is a 5 no and 5 yes class. Okay. So, so then the probability of yes is 5 by 10, 0.5, and body no is 0.5. So calculate Gini Also, we need to find the probability, calculate the probability of classes for different data set. I mean, for split data set. To calculate the Gini, actually, this is a formula. There is a formula like Gini equals to 1 minus the probability of the classes. I mean, sum of the square of the all the class probabilities. This is a formula. 1 minus p1 square plus p2 square. Okay. So here only two class yes or no. So that means the is formula like 1 minus p1 square plus p2 square. Okay. So this is actual formula. So for the our initial data set, as the probability of yes is 0.5 and probability of no is 0.5, because 5 by by 10 this. Okay, from there here we can find this. Okay, now let's calculate the Gini. As per the formula, 1 minus 0.5 square, I mean probability 1 class 1 square plus probability class 2 square. So, and we got this one, and finally the result is 0.50. So Gini for the initial data set is 0.50, and as per the our table, the highly mixed, right? Understood how to calculate Gini? Now go to the next. It's an important step. Now, how as per the recently so as per recently algorithm, the algorithm asks the dataset one single question at a time, and based on the question, it will split the dataset. Okay, but what question you should ask first? It's a very important thing. Let me explain on this thing. Suppose the algorithm tries to obtain credit score seven more than greater than 700. Okay, this question. So that means left group. If I split based on this, so left group store the greater than 700 score, and right group less than equals to 700, right? So as per the this condition, the left groups the customer group have the customer A, B, C, D, E as per the above table. A, B, C, D, E. Actually, there is sorted by the credit score. That's why you can easily identify. And from F to J has the below or equal to 700. Okay. Yes. Yeah. So that means from the above table, so ABCD all know. That's why no equals to 5 and ES is 0. No ES there. Same thing for less than equals to 700. ES equals to 5, but there no is 0. For both the left and right group, if we calculate the Gini, you can see Gini equals to 1 minus probability of no plus probability of yes. It is 0. So probability of 0 square and probability of 1 square. Okay. Same apply this. I mean, apply the same equation for right group, and Gini is 0. So this is external split because both child groups drop from Gini this to Gini 0. As I said before, the Gini, if the value is Gini is 0, that means very perfectly pure group. Now let's say another split like income is greater than 60K. And here in this case, left side contains 3 no and 2 yes. So in that case, the pure probability of no is 3 by 5, 0.6, and pure probability of yes is 0.4. So apply the Gini logic Gini equation, and the calculated Gini is 0.48. And for the right side, 1 no and 4 yes, and calculated Gini is 0.32. So if I compare this income versus credit score, here you can see the credit score Gini is less than the income. So that's when credit score split uh, gives a purer group. So if we only take working with these two feature, income and credit score, then our algorithm, I mean decision tree, will ask these questions first. Then it will ask the income. So in the first node, it will first data will be split based on this, and second split happen on this data set. Okay. So why square the probabilities? Also can this question may arise because if you find the equation is a formula, then see the here the formula is 1 minus probability of class 1 square plus probability of class 2 square. So why we are squaring? Not only the not why we not takes only the probability? Actually, so for pure, let's see, yes equals 100%, no 0. In that case, so 1 minus everything is 0. So that means only 1. But for the mixed group in the our initial where the yes and no are equal number, in that case, if if I um, if we not square it, so 0.5 plus 0.5 it will sum up to 1, and that means it will give the purity is 0. That means it's wrong, right? If the purity is 0, that means it seems like they're perfectly pure. Okay, but if we square the probabilities, it gives a 0.5. That means it's indicate that it purely not sorry highly mixed. So that's why we're squaring to reduce the Gini. So not Gini, sorry, reduce the quality value much smaller from 0.5 to now became 0.25, right? Again, I just will give you the deeper example so that you can understand the whole everything clearly. Because here I have shown you the only the credit score 700 greater than income only 60K. But why choose the 700, not the other values? Because lots of values in the present in the credit score. Same for the income. Okay, why speak only 700, not the 780, 650, 600? Why not? Same for the income, right? Actually, this is our data set. So actually, what happened? I'm just verbally saying. First, um, it will split for every value. Say for the credit, okay, and then calculate the Gini weight, and then compare all the Gini weight and choose the best one. Same for the income. So it's not just that, it's first pick the random value and decide. So it calculate the Gini, not the Gini. I just till now I just shown you the how to calculate Gini, not shown you the how to calculate the Gini weight. It's actually calculate a Gini weight for all the uh, different values present in the feature or column, and then decide the choose the best one, purest one. Let's uh, explain the how weighted Gini calculated. The question is left samples by total sample into left Gini and right sample by total sample into right Gini. This is the formula of weighted Gini. So if I choose the income greater than 50, then if I apply the same equation or formula what I have shown here for to calculate the 60k, we do the same thing and we will find I have found that the Gini is 0.32 for left node and right node is 0. Okay, and so left sample is 5 and total sample is 10. So that means for the left side, calculate value is actually we have the left sample by total sample in multiply Gini of the left side, and we have found the 0.16, and for the right the same calculation and found the 0.00, and the total if we sum up the left and right we will get the 0.16 weighted Gini. So for the income greater than 50, the weighted Gini is 0.16. So same way we calculate for all other values and choose the best one. Here you can see we have tried other income and also calculate the weighted Gini, and here you can see 60 more 60 greater than 60 if the lowest weighted Gini, that means is the best one. Same for the credit score, this one. Same for the loan amount, this one. And at the last we compare between the features. So for the if we compare the income, credit score and loan amount, whose Gini is smallest? The credit score Gini is smallest, right? So that means recently they will ask this question first, and then choose the loan amount as second, and then it will ask the income. So another question is that is the when calculate the Gini for all values for the particular feature, like suppose credit, lots of double 780, 760. So Gini actually calculate for all its value or randomly pick. No, actually it's, let me explain. So it typically takes a split between points between the consecutive sorted value. For example, if the value is like this, so split threshold then for those for these values are the midpoints. That is for 3 and 45 it is 32.5, 4 and 45 it chooses 37, like this. Actually, it not takes this value, but instead it takes a uh, midpoint of the two consecutive number and calculate the weighted Gini and compare and choose the best one. So let me explain the flow of the algorithm. That is, first select any feature, suppose income, sort all the values and generate a midpoint. Yeah, one thing I just missed. It is to choose the threshold. Actually, a midpoint. First, it actually sort the value, then it find the midpoint. Okay. So then split the data for each point, calculate left and right Gini and weight, and choose the lowest weighted. So this is the step. Okay. So Gini impurity measures the how mixed a group is. The dictionary tries every possible split and choose that one that produces the purest child group. The dictionary does not know the first question beforehand. It automatically tries every possible question and mathematically select a winner, as I shown. So that's all for today. Thank you.